Hello, welcome to this demo. Today we will see a complete change data capture scenario between two microservices deployed on OpenShift. The challenge of that demo is to reach the following architecture with less code. For that, we will use Syndesis, Strimzi, which is Kafka on OpenShift, and finally Debezium for CDC. In that demo, we will start first by deploying two microservices on OpenShift with two different databases. The first microservice will consume from a REST endpoint and store data to MySQL database to the products table. Debezium will stream changes from MySQL database and send it as a message to a Kafka topic. The second microservice will consume those messages from this Kafka topic and store data change to his Postgres database to the products table. Let's start now by installing Syndesis and deploying those two microservices. Before installing Syndesis, I have installed first the two databases that are required for our microservice, the MySQL database and the Postgres database. For each database, I have created the products table with the same data. Let's start now by installing Syndesis custom resource definition. Now we can proceed with the installation. Once the installation is complete, you can access to the Syndesis web interface. Now we can start by creating our first microservice. The first microservice consumes from a REST endpoint and store data to a MySQL database to the products table. We will start first by creating the connection to this MySQL database. For that, we choose database. We'll provide the connection URL, the user, and the password. We can check directly if the connection to this database is correct or not, and after we can provide a name to this connection. Now we can start directly our integration, and for that we choose the API provider. Let's create our API, product API, the path product, and for data type, let's say product data, and we can provide a JSON example in order to configure all the properties that will be received by this REST endpoint. Now with all the properties that will be received by this product data. Let's save this. Let's return. For the moment we will create only one operation. Let's call it create product. Same for summary, same for description also, and we can define the request body is the product data that we have set before, and the response we can say that only we would add the response with HTTP code. Now our product API is ready. We can save it and we can continue now. create our microservice. Now we will add our MySQL database. And we will invoke this SQL statement in order to store our data. We have some data mapping to do here between the metadata received by the REST endpoint and the metadata required as input for the insert SQL request. Let's give a name to our first microservice. This will be built, deployed, and published by Syndesis. Since we have deployed our first microservice, now we will proceed with the installation of Strimzi, which is Kafka on OpenShift, and Debezium. We will start first by installing the Strimzi cluster operator, and we will create our Kafka cluster with 3 nodes. Once it's started, we should see 3 Zookeeper pods and 3 Kafka pods. Now everything is installed and up and running. We can see Kafka, Zookeeper, and the cluster entity operator. Now we will proceed by installing the Debezium MySQL connector. And for that, we start with deploying the Kafka connectors to image. This will create a build config. Called myClusterConnect, myConnect and we try to include all the plugins of Debezium here. We can see they are already downloaded from Debezium, and the most important for us is the one with Debezium connector to MySQL. And for that, we will start a source to image build in order to include those Debezium connectors plugins to our Kafka Connect image. Now we see that the build is finished and the new image has been pushed to the internal registry. By default, Kafka Connect exposes a service with the REST API to manage Debezium connectors. Let's expose this service as a root in order to get access to it from outside OpenShift. Here is the URL that we have to invoke in order to create our Debezium MySQL connector. We need to get the cluster IP of MySQL service. This will be required in the properties of our creation request. Here we go. Now my curl command is ready to create our Debezium MySQL connector. We can see from the output that our connector has been already created. We are ready to jump to our second microservices, and the second one will consume messages from Kafka topic and store data to the Postgres database to the product table. We have created our Postgres database, and now we have to create the connection to our Kafka worker. And we have to get the cluster IP of my cluster Kafka Bootstrap, this one. Put this. can validate the connection and we can proceed with Kafka connection. Now we have everything in order to start our second microservice. We start from consuming messages from a topic. We have to choose this topic, which is dbserver1.inventory.products. Here we have to provide an example of the JSON payload received from the topic in order to recognize the metadata. And we can proceed. And now we have to choose our Postgres database. We will invoke the SQL statement. Now we have to do some mapping here based on the payload received. Now we have to provide a name to our microservice and publish it. We have both microservices up and running. We can test the entire implementation. For our test, we will connect the both databases in order to see the data stored in the products table. We will create a subscriber on the topic where Debezium generates the message when he captures the data change on the MySQL database. And finally, we will trigger the REST API by sending a post request. Here we have the connection to the MySQL database, and we see the data that are stored on the product. The same on the Postgres database. We see here all the data that are stored on the products table. Here we will create a subscriber for our topic where Debezium will generate his messages. And now we can invoke our REST URL. We can get the URL of the external URL of our REST API from here. We can copy it from here. And now we can send a request to our REST API. We'll create the following product. As you can see here, we got the answer from the REST API with the HTTP response code 201. Here we can see the message generated by Debezium with data change on the products table with the new data stored. Now in my SQL database, let's see if our new product has been stored. Yeah, it's stored as you can see here. And now let's see on the Postgres database if we have exactly the same data stored. Here is it. We can see here the same product stored as well on the products table in Postgres database. Hope you enjoyed this demo and see you soon.